Welcome to the Spring Boot course where we're going from complete beginner to building production-ready REST APIs. I'm really excited about this course because we're not just going to learn theory, we're going to build a real application together. This course is ideal for beginners, but also for those people that are just looking to brush up their knowledge on building REST APIs using Spring Boot. Let's start with the main question: what is Spring Boot? Think of it this way: Spring Framework is incredibly powerful, but it's also complex to set up. Spring Boot takes all that power and makes it simple. It's like going from building a car from scratch to getting one that's already assembled. You just need to drive it. By the end of this course, you'll have built a complete task management REST API. You will be able to create, read, update, and delete tasks, search and filter tasks, handle validation and errors properly, and make it production ready. Before we start, you should know basic Java, such as building classes, objects, methods, and OOP concepts. The rest we will cover in this video. We are ready to start now. First thing first, we need to create our Spring Boot project. Spring makes this super easy with Spring Initializer. So open a browser page and head over to start.spring.io. And let me walk you through the options we're going to see on this page. So project type, we're going to be using Maven. Maven is going to handle our project dependencies. It's the most common one used in the industry, but Gradle works too. Language, of course, we're going to be using Java. Spring Boot version, we're going to be using the latest Spring Boot 4. I also suggest you avoid using these snapshots for learning especially. So let's stick to Spring Boot 4, which is the latest stable version. This is usually the company's domain, so in this case LeetJourney, but it can be anything for you and it's written in reverse order. Then we want to give a name to the artifact. So in this case, we're building a task manager. So let's call it task manager. Name looks good as well. Package name is autofilled and this is good. It's basically the group plus the artifact name. Description, this is optional, but we can add task management REST API. For Java, if you're using Spring Boot 4, you need to make sure that you're using at least Java 17. In my case, I'm going to be using Java 21. Packaging, we're going to use jar. And configuration, we're going to be using properties. There is also the option to use YAML configuration. In industry, most of the times, Application.properties is used, so this is the standard really. Now the fun part, dependencies. So these are the dependencies we're going to need to build this task manager REST API. So let's start by adding the first dependency, Spring Web. So Spring Web gives us everything to build the REST APIs. We then want JPA, which is Spring Data JPA. This is needed for database operations. For now, we're going to start with an in-memory database. So we're going to be using H2 database, and this is okay for learning, but later on in the video, we are going to change this with something else, which is used in the industry. So for now, let's start with H2 database. We are going to be using Lombok. This is going to reduce boilerplate code. And for validation of the input, we're going to be using validation. Click generate, and this is going to download a zip file that is going to contain our project. We want to extract this and open it in an IDE. I'm going to be using IntelliJ, but Eclipse or VS Code work great too. Let me show you our project structure. The pom.xml file you see here has all of our dependencies that we're going to need for now. The main application class is here under source, main, Java, and under the main package. And under resources, we've got Application.properties. This is where we'll configure things. Let's start by running this project we just downloaded. So let's create a configuration. If you go at the top, click Edit Configuration, click on plus, Application, let's call it Task Manager. we want to select our main class, which is Task Manager Application. This is the default class that comes with Spring Initializer, and the rest we can leave the same. Let's click Apply, OK, and let's run this application. See that Spring Boot has just started a web server on port 8080 using Tomcat. Look at all this auto configuration happening. We didn't write any XML configuration or set up any code, and that's the power of Spring Boot magic. Let's start by writing our first endpoint to prove that this application actually works. So let's close this and let's stop the application for now. Go to the main package, right click, and let's create a new class. We'll call it hello controller .java. In here you want to add a tag, REST controller, and let's create an endpoint. So let's create a get mapping /hello public string, say hello, and we do hello world. So let's start the application again. We can see this has started successfully. Again, we have a Tomcat server running on port 8080. So now open a browser page. I'm going to be using this integrated browser I have installed. And let's go to localhost 8080/hello. So we are going to be calling this endpoint. Let's see what happens. You can see hello world is getting printed. Beautiful. We just created our first REST endpoint in about 10 lines of code, and we didn't have to do any kind of configuration, and that's to show you the power of Spring Boot. Before we move on, let's understand what has just happened. Let's go back to our main application class, and let's start by looking at this code. So let's look at this tag, Spring Boot application. This annotation is doing 3 things. So this one tag is equal to 3 tags. So the first one is configuration. This tells Spring that this class can have configuration. Then this says enable auto configuration. This is where the magic happens. Spring Boot looks at our class path and auto configures beans. And then we've got component scan. This scans package and sub-packages for components. So these 3 tags can be translated to this one tag at Spring Boot application. If we go back to our controller, when we added the REST controller up here, Spring component scanning found it automatically. So component scan found this component, the controller component, and we didn't have to register this anywhere, it just works. This is actually called Spring magic. Auto configuration is why we didn't configure a web server. So we can see we got a Tomcat web server running on port 8080. Spring Boot saw that we had Spring Web on the class path and thought they probably want a web server, so it just configured Tomcat for us. Traditional Spring requires a lot of XML or Java configuration. Spring Boot says, I'll guess what you need, and if I'm wrong, you can just override me. That's the difference between Spring and Spring Boot, and that's also one of the reasons why Spring Boot is used more in the industry nowadays. Okay, now that we understand the foundation, let's build something real. Let's start by creating our task entity. This is going to represent a task in our system. So we want to create a new package called entity, and let's create a new class called task. Let's add a bunch of annotations, data, no args constructor, all args constructor. Let's add some class attributes. So we want a ID, a title, description, whether the task is completed or not, and also local date time created at. So you see these Lombok annotations. Data gives us getters and setters, toString, equals, and hashcode methods. No args constructor and all args constructor create constructors. So this one creates an empty constructor with no arguments. This uses all the arguments that we have defined in the attribute list. And these 3 tags saves us writing 50 plus lines of boilerplate code. Right now, this class is just a Pojo. Pojo stands for plain old Java object. Soon we are going to turn this into an entity for database persistence, but let's walk before we run. Now let's create a proper controller. So let's delete this hello controller we created. Delete, okay. And let's create a proper package. It's important when you're creating any kind of application to have your code well organized, or as it grows, it's going to become a mess. So let's create a package called controller. And in here, let's create a new class called task controller. You can think of a controller as the entry point into your application. In the controller, you're going to have your endpoints. So let's create a proper controller this time. So this again is going to be a REST controller. So we need the REST controller tag, request mapping, API v1 tasks. So what is happening so far? With this REST controller, we are combining 2 tags into one. So 2 annotations, which are controller and the response body. Every method in here returns data, not views. So this is why we are going to be adding this annotation REST controller. We then have request mapping. This is the base path for all endpoints in this class. So you know when you're calling a REST endpoint such as localhost 8080, then you got a base path, and then you could have something else like search or search by status, something like that. So this request mapping defines the base path. Now let's create the actual endpoint. So let's start by creating a get endpoint using get mapping. This is going to return a list of tasks, and this is called get all tasks. And we want to return all the tasks we've got. So return tasks, typo here. We want to import list, and tasks, we want to create a list of tasks and return that. For now, let's create temporary in-memory storage. So private list tasks equals to new array list, and private long next ID equals to 1. So what have we done so far is we created a get endpoint, which is going to return all the tasks in this list of tasks. For now, we are using an in-memory list. I know it's not a database yet, but this lets us focus on the REST concept first. So let's start our application and let's hit this endpoint we have just created. So this time, instead of using a browser, I'm going to show you a different tool, which is an actual tool that you can use to send REST APIs. So let's close that. And this is how it's called, API tool. Is literally the same as Postman or Insomnia. Feel free to use whichever you feel more comfortable with. I'm gonna be using this so I don't have to be changing through screens. So as I said, on your browser or in a REST client tool, let's call this endpoint localhost 8080/API v1 tasks. We want a get request, and let's click send. You can see nothing is getting returned as we expected because there is nothing in our in-memory task list. So this is perfect. An empty array is getting returned because we have no tasks yet. So let's start by adding some. It's time to implement full CRUD. CRUD stands for create, read, update, and delete. So let's start with create. We want to create a post request. So post mapping, public task, create task, and as a request body. So when the user calls this endpoint, he's going to send us a request body, which is going to represent a task. And then we're going to be using this task and set an ID. So task.setID. For IDs, we're going to be using this in-memory long variable, and we're just going to update it as we set these IDs. And then let's also set task.setCreatedAt, local datetime.now, and task.setCompleted equals to false. And then we do tasks dot add, and we add this task to our list of tasks up here. Once we've done all of that, we are simply going to return the task. So not tasks, but the single task, so that the user is going to be able to see the ID, the created date, and the newly created task set as not completed. So in this case, post mapping handles HTTP post requests. Request body tells Spring to convert the JSON in the request body to a task object. So this is automatic JSON parsing provided out of the box by just using this one tag. So we are ready to test this post endpoint. Let's restart our application. Let's go to our API tool. If we refresh, we're going to see the post request. So you can see it goes to the same endpoint, but this time it's a post request. And in here, we do not want to send an ID. So this is the limitation of this tool. So we have to be careful. So we just want to send title and a description. So let's say learn Spring Boot, description, complete LeetJourney tutorial series. Let's click send. There is an error, so let's see. Okay, so the error makes sense. The JSON parser cannot map null into data type boolean. Let's go to our task entity. We can see here that this is a primitive boolean. So a primitive boolean is either true or false. It cannot hold the value null. So we have two options, either pass a completed attribute in the request body, or we can make this not native. So let's use boolean. So this way, this can be deserialized to be null. It might have some other implications. We might have to handle null later on, but for now, I would say let's transform this from a primitive to a class type called boolean. Let's restart our application. Let's go back again and let's send this request again. So we can see the post request has created a task with ID 1. Completed is equals to false, and there is the created time. Now let's get all tasks. So let's go to the get endpoint. Let's click send, and you can see the task we just created is getting returned. So this get all task is going to return us all the tasks in our in-memory list. Let's do one thing now. Let's create a new endpoint and let's get tasks by ID. So let's put it down here. Let's create a new endpoint, which is going to be again a get mapping. And this time we want to send as path variable an ID. And this is going to return as a task. Get task by ID, path variable long ID. And let's return from tasks. Let's use streams. We want to filter and we want to find a task where the task.id, task.getID, is equals to the ID we have passed as a path variable. Let's find first. If we can't find anything, let's just return null. So what is happening here is in this get endpoint, we're also going to send as path variable this ID. So this path variable is going to extract the ID from the URL, and using Java streams, we're going to find the task or return null. So let's restart our application. Let's go to our API tool, and we can see we've got a new get endpoint with a path variable. So in this case, let's first do a get all, and you can see nothing is getting returned, and that's because we are using an in-memory list. So every time you restart, this is going to be empty for now until we implement the database in our application. So let's quickly call the post again. So let's just do title, hello, description. Let's click send. Now we know that that task we just created has ID 1. So let's send ID 1 and you can see only this task is getting returned. Let's go to the post request again. So let's create another task. Let's call it task 2 test. Click send. So this one has ID 2. Let's go to the task by ID. Let's get the task with ID 2. And you can see only the ID 2 task is getting returned. But if we call the get all tasks, this is returning both as we expected. So far we have implemented 2 of the 4 CRUD operations. Now let's create an endpoint for updates. So put mapping. We want to pass the ID of the task we want to update. Public task, update task. Again, as a path variable, we are going to have the ID of the task, and then as a request body, we are going to have the update parameters for that specific task, so updated task. So what are we going to do here? So what is happening here is we're using a for loop to go through the list of tasks. By the way, we could have also used streams, but let me show you this way. I think it's just clearer. Sometimes using streams might confuse people. It's always a trade-off between readable code or efficient code or using the latest technologies. In this case, let's just go for a for loop. Let's go through the list of tasks we've got in memory. Let's get each task. If this task ID matches the ID of the task we want to update that we've sent as path variable, what we're going to do is we get the updated task and we set the ID of this updated task to be the ID of the retrieved task, and the same for the created app, because we do not want to allow the user to update these 2 attributes. Once that's done, we are going to replace inside the task array list the updated task with the original task. So at position I, we want to put this new updated task, which is going to have the same ID as the original and the same created time as the original one. And then we simply return the updated task. So for a put request, we find the task, update it, and return the updated version. Let's restart our application. First, let's create a task. Let's call it T1 test. Let's click send. So this has ID 1. Now we want to update this. Let's use the put request. As path variable, we want to send the ID, which is 1. And as body, so we do not want to send the ID again. And also cannot allow the user to change ID. What we can do is we can update the title of the task. So let's say instead of T1, we want to call it task 1. Description is task 1 description. And let's set this to true now. Let's say we have completed a task. We want to set it to true. Let's click send. You can see the task with ID 1 got the title and description updated. The created time is still the previous one, and completed is equal to true now. If we do a get for task 1, we can see that this has actually been updated. Finally, let's implement the delete endpoint. So delete mapping, we simply want to pass as path variable the ID of the task we want to delete. Public void delete task. Path variable, we pass the ID. Tasks.removeIf. So if the task.getID is equals to the ID we have passed, we remove it from the tasks list. And it's as simple as that. Feel free to test this one out. It should just work. Let me quickly go through HTTP status codes because they matter. So if you noticed, when we send requests, we get a status code back. So in this case, when we did the get, we got a 200 back. Let me quickly add a note here. So there are various HTTP status codes, and they're mainly split into groups, and each group starts with a different number. Let's just go through the main ones. So we have usually a 200, which is HTTP status OK when we have successful for get, put, or delete. 201 stands for created, and this is usually sent back for post requests which were successful. 404 is returned when the resource doesn't exist, and 400 is returned when we send a bad request. We will improve our status codes later on, but for now we have a working CRUD API. Next, let's make this persist data to a real database. Let's now move on and let's talk about data persistence with Spring Data JPA. In-memory lists are fine for learning, but they disappear when the app restarts. So let's add a real database persistence with JPA, which stands for Java Persistence API. If you remember, when we first created the project, we added a H2 database, and we can see that we've got the dependency in our pom.xml file. So we are good on that side. So let's go back to the Application.properties, and let's add some H2 configuration. So let's start with Spring Data Source.url equals to jdbc h2:mem:/taskdb. So in this first line, we are creating an in-memory database called taskdb. Let's move on to spring.datasource.driver class name. And we want the driver class name to be org.h2.driver. So this is something we need to be able to connect to the H2 database. Let's move on. Let's also add data source.username. This is going to be the username of the database we are creating. So in our case of taskdb. Password, we can have password. So this is H2 configured. Let's now configure JPA. If you're using an old version of Spring Boot, with old I mean something that is less than version 4, which is the latest one, you want to define the dialect that Hibernate has to use in order to speak to the database. So Hibernate is just an implementation of JPA. JPA is a set of standards that allow us to connect to a database in very simple words. So if you're using an old version, you will need to add this. In Spring Boot 4, this should not be needed anymore, but I'm still going to leave it here. In case we have issues, we can just come back and comment it out. Spring.jpa hibernate ddl update. This line is going to auto-create and update tables based on entities which we have in our code base. So we already created an entity which is task. We will need to do some changes to that, but once we do the changes based on what is in that entity class, Hibernate is going to automatically create those tables in our H2 database. And that is perfect for testing and learning. In production databases, we usually follow a different approach where we have a database migration tool such as Flyway to handle database DDL operations. I have a dedicated video on that. You can check that out as well. And let's also show SQL. Basically, we are going to print SQL queries to console. This is good for learning. You want to be careful in production because you don't want to log sensitive data. So in our case, we're just learning, so that's fine. And last but not least, let's also add some configuration for the H2 console. So we have this database running, but we want to be able to see what's inside the DB. For that, we have a console, which is basically a UI, which allows us to connect to the in-memory database. So we want to set H2 console enable equals to true, and we want to simply set the path equals to h2-console. So these are all the configurations we need for now. Let's move on now and let's open our task class. You can see we already put it in the entity package, but this is not an entity yet. This is a Pojo. So let's turn this task Pojo into a JPA entity. We can leave these tags we've got, but the most important one is the entity class we want to add from Jakarta Persistence. And we also want to add a table tag with the name of the table. So what we are saying here is this entity represents the table called tasks, and this entity tag marks this as a JPA entity. We now need to also do some changes in the body of our class. an entity needs an ID. So our ID is going to be this long ID attribute we already have. And we want to have this as auto-generated. By definition, an ID has to be unique. We're simply going to put strategy equals to generation type dot identity. We can now define some properties for these columns. These attributes represent columns in our tasks table. We can give some more information to JPA on how to create these columns in the DB. So let's add column and let's define nullable equals to false. This is going to make sure that this title is not going to be false. For description, we can define a length of 500. So if you know a bit of SQL, usually a string is defined as a varchar. And when you define it as a normal MySQL DDL code, which stands for Data Definition Language, where you define the properties of each column, you're going to define the length of a varchar. In our case, using these tags is going to achieve the same thing, and this will be automatically picked up by the JPA. Next one, completed. This can't be false either. So nullable equals to false. And let's also assign a default value, which is going to be false. So let's add equals to false. Created at, so this is going to be column name, created at. What happens is that this camel case is actually translated into this underscore version. And this is the actual column name in the DB, because that's the standard for column names to have this underscore. If your attribute name inside the entity class does not match the column name, you want to actually add the name tag. In case the only difference is the camel case, that is fine. JPA is smart enough to be able to understand it on its own. So in theory, this is not needed. So we can leave it here or we can remove it. For learning purposes, I'm going to leave it here. So we don't want this to be nullable and we do not want this to be updatable. So once a task is created, you don't want the users to be able to update it. Also for auditing purposes, if you were to create a real application. And here, let's also add a pre-persist tag. This is a protected method. So protected void. On create, we want to set created at equals to local date time.now. So whenever we create a new task, we automatically are going to set the created time. So this one runs just before we save to the DB. Let's now run our application and let's see what happens. Okay, do you see this log? Hibernate, create table tasks. And then we have a bunch of columns with their type, and we've also got some properties that we have defined. We've got the description varchar 500. Hibernate, which is the JPA implementation, as I said, has just created our table. So let's now view this table in the H2 console. So let's open a browser page. So in a browser, you want to go to localhost 8080/H2 console. You are going to see this page. You want to leave everything unchanged. The username is going to be SA, which is what we defined in the application.properties, and the password is what we had defined in the same application.properties file. So in our case, this was password. Let's click connect. One thing we forgot, this is not a test DB, this is called task DB. Let's add password again. Let's click connect. And this is what we're going to see. This is our DB, task DB, and this is the table that has just been created. If you expand that, you can see all the columns in this table, and we can also query this table. So if you click on the table name, it's going to give you a generic select query to get everything in our task. Let's run this, and we can see there is nothing right now. So this table exists, but it's empty. Let's now create a repository to interact with the table we have just created. So let's go back to our main package and let's create a new one called repository. In here, let's create a new class called task repository. So the standard for creating a repository interface is actually having the name of the entity plus the keyword repository. And this is going to be an interface, not a class. So let's add this tag for now, but we're not gonna need it, and I'll explain it in a minute. So we want this public interface to extend JPA repository, task, and long. I'm going to explain what we have just done. So you might be wondering, why do we have an interface with no methods? This is Spring Data JPA magic. So this extends JPA repository, tells Spring that you need to work with task entities, and the ID type of this task entity is a long. And Spring Data is going to auto-generate for us an implementation for save, find all, find by ID, and many more methods. So if you go in here, you can see some of the methods that we are going to get for free from Spring Data JPA. You can see this JPA repository also extends other interfaces. So if you click on it, you can see find all, save all. These are all provided to us for free. We don't have to write any kind of implementation. So if you go back to our task repository, I told you this repository tag is not really needed. Spring Data is automatically going to detect and create a proxy implementation and is going to register this class as a bean. So this works because Spring Data's repository infrastructure performs class path scanning for interfaces that extend the repository, CRUD repository, or JPA repository. So a bean is automatically going to be created. A bean is a Spring managed class. What I mean by that is that Spring is going to create a singleton. A singleton is an instance of a class that you can simply use throughout the project. It's going to be clearer later. I'm going to explain that more in detail later on. I do not want to confuse you too much. I know this might be already a bit hard to understand and it takes time, so don't worry. So we have our task repository. We wrote the interface and Spring is going to write the code for us. And this is why developers love Spring Data JPA. If you're finding this video useful so far, please don't forget to like and subscribe, as making this kind of videos takes a really long time, and a like would be really appreciated. Thanks. So let's move on. Let's now go to our controller class and let's refactor it to use this new repository class we have just created. So we can get rid of this temporary in-memory task list. And instead of this, we want to add the private final task repository, and then we're going to use constructor injection to inject task repository inside the task controller. So let me try and explain this in a very easy way. So I was just talking about Spring beans and Spring singletons. What happens is that Spring Magic is going to create an instance, by instance I mean a bean, of this task repository. Now we want to use this task repository inside our controller class. We can simply pass it inside the constructor as an injected method. And to inject it, we are going to have this task repository passed as input, and then we're going to set this controller's task repository as the task repository passed to the constructor. So you can see I've also added an autowire tag. This is more to explain you that this is something that Spring is managing, but Spring Boot has become really smart. This is not needed anymore because when you have a single constructor, Spring already assumes that this is auto-wired. Here you want to use constructor injection. So this is not needed, but I'm still gonna leave it there as a comment. So what I was saying here is that task repository is a bean managed by Spring. So we have an instance of task repository somewhere inside Spring. When we want to use it, we can inject it as a constructor parameter, and this is called constructor injection. So this instance will be set inside task controller, and this is also called a singleton. And a bean is also a singleton because we usually have one instance of each class, and Spring is going to manage all of that. We do not need to do something like task repository equals to new task repository, etc. This is all handled by Spring Magic, and we don't have to worry about that. By the way, these concepts are not easy to grasp the first time, so you are going to need some practice. Don't worry if you don't get them right now. Practice is going to help a lot. So now, in here, where we're using the list, what we're going to do is we're going to use the task repository, and we are going to get these methods for free. And you can simply just do task repository find all, and this is going to find all the tasks in our DB. Let's also change the get task by ID. So in here, we are going to now return a response entity task, get task by ID. This is going to give us more control over HTTP status codes and headers. Let me show you what I mean by that. So let's remove this. Let's do return task repository dot find by ID. As you can see, we didn't have to write any of these methods. These are given to us by Spring Data JPA. Once we get the answer, we do response entity OK. Otherwise, response entity not found.build. So you can see we've changed the return type to be a response entity task. So this response entity now allows us to return a status code. So in this case, OK, if we find one with the task. Otherwise, we are going to return a response entity not found. So this is going to return a different kind of status code. And this is quite handy. Let's move on. Let's also change the post request. So again, this is going to return now a response entity task. And simply what we want to do here is, let's get rid of what we had. Code is going to be way shorter. So what we're going to do is we're going to use task repository dot save, and we're going to save the task we get as input. Once this is saved, we're going to get back the task that we just saved with the new ID and the created@time set. And then simply we're going to return response entity status 201. So let's say we want to make this readable. We can have HTTP status dot created and the body of the response entity to be the saved task, the task which we have just saved and has been returned to us by the task repository. Let's also rewrite the update. So let me just remove it. So again, the response type is going to be response entity task. And now we want to return task repository dot find by ID. We want to first find it by ID if it exists. And then what do we want to do? We want to get this task that we just found in case we find it. We do the same things as before. We set the title, description, set completed to be what has just been passed. And then we use the task repository to save it in the DB. And then we return response entity.ok with the saved task. We could also call this updated task to make this more readable. Updated task. Okay, we can't call it updated task because that's the input. So let's just leave it saved task. Or else, if we can't find this task in our DB, it means that it doesn't exist. We're going to return response entity not found.build. And finally, let's also update our delete mapping. So this is going to return a response entity void. And in here, we want to do return task repository dot find by ID, and then we want to take the task in case it exists, delete it from the repository, and return response entity dot ok dot void, and we build this void response entity. Otherwise, we return response entity not found. Let's now test this. We have done a lot of changes. Let's see if this still works. Let's restart our application. Let's test the post request. So we want to send only the title, let's say by milk. Let's say full fat milk. Let's click send. So there is an error. Let's see. We might have missed something. Okay, we have to send also completed. Let's set it to false. Let's click send, and you can see this has been created. Now let's also create a new one. Let's say buy vegetables, I don't know, broccoli, cauliflower, etc. So let's click send. This has also been created. Let's do a get to get all tasks. And we can see these are being correctly returned. There is no issue. If we go back to our console, let's query the task table again. You can see these are being correctly saved in our database, which is a in-memory DB. So one thing to remember is that because this is a in-memory DB, every time you restart, this DB is going to be wiped. So there are different strategies to save this in a file, for example, whilst you are testing. So you don't have to create these every time. For now, let's just use this in-memory DB. We have achieved real database persistence over here. Let's go back to our code and let's take a look at our task repository. So JPA has given us basic CRUD. What about custom queries? Let's add some. Method name query. We want to return a list of tasks, find by completed, and we're going to return as input a boolean completed. Spring Data JPA has query derivation. It reads method names and generates queries. So this one, for example, is going to be translated into the following query. Select from task where completed is equal to the input variable completed. This is what this will look like. And Spring Data JPA can do it automatically by just reading the name of the method. Let's add another custom query. Task find by title containing ignore case string title. So this is going to ignore the case and find title that contains this title we pass as input. And we can also write custom queries using JPQL query. So it looks something like this. We want to define what we want to get returned. We want to give it a name, so find tasks by completion status. As a parameter, we are going to give completed, boolean completed. So what this is saying is this input is going to be a parameter inside our JPQL query. Now we want to define our JPQL query. So we are going to add the query tag, select T from task T where T.completed is equals to completed. So you can see this task is the same as the name of the entity. So Spring Data JPA is quite intelligent. It already knows that this is the entity. So we're going to return everything from this task table where the completed is set to whatever we pass as input. And then this is going to be auto-deserialized to a list of tasks and you don't have to do anything. So for complex queries, we can use this query tag with Java Persistence query language. It's like SQL, but uses entity names, not table names. So let's add some endpoints for these custom queries we have just written. Let's go back to our controller. Let's add a get mapping for completed with status as input. Public list of tasks. Get tasks by completion. Path variable boolean status, and then we're simply going to use find by completed, which we have just written. Let's do the same for the search. Let's do get mapping search, and let's pass this as a request parameter instead of a path variable. So public list task search tasks by title, request parameter, string title, and we're going to use find titles containing ignore case title. And you can go on and create one for this other custom query. Okay, let's restart our application and let's test these we have just created. Let's test one of them. So as I said, the data is going to get wiped every time you restart. We will need to save this somewhere. But for now, let's just quickly create a task. Let's create another one, which is called hello test. And let's now test one of the new endpoints. Let's do search by title. So let's refresh this. And we need to pass a request parameter. Let's say hello. And you can see it only returns the task where the title has hello in it. And to confirm, we can get the list of all tasks. And we can confirm that these new custom queries are working. And if we have a quick look at the console, you can see Hibernate is logging the queries that are being sent to the database. So this is incredibly powerful for building search features very quickly. So we have seen how easy it is to use Spring Data JPA to query a database. And look at the console. You can see the SQL query Spring generates. This is incredibly powerful for building search features very quickly. If you're liking my videos, please don't forget to become a member to support the development of more free content on my channel. Thank you. Right now, our controller talks directly to the repository. This works, but it violates separation of concerns. Think about it. What if our business logic gets complex? For example, what if we need to send an email when a task is created? Or what if we need to check if a user owns a task before we do an update operation? Putting all that in the controller makes it bloated and hard to test. The solution for this problem is adding a service layer. The service layer is going to sit between the controller class and the repository. That way we are going to have different classes dealing with different concerns, so we are going to achieve separation of concerns. The controller is going to handle HTTP, validate inputs, and return responses. The service layer is going to handle the business logic, orchestration, and transactions, while the repository is going to handle database operations as it already does. This will make our code easier to test, easier to maintain, and reusable. So let's start and refactor our controller class, and let's add the service layer. To do that, let's start by adding a new package called service. And let's create a new class called task service. We are going to tag this as a service class. This tells Spring to mark this class as a service component, and Spring is going to manage its life cycle. And we also want to add transactional, so this class is going to sit between the controller and the repository. This transactional tag is going to tell Spring that database operations run in transactions. If something fails, everything rolls back. It's super important for data integrity. You do not want half committed operations in your database. You either want to have the whole operation being successful, or you want to roll back the whole state of the database to whatever it was previously before we started the actual change. So the task repository is going to go in here now, private final task repository. And we're going to use constructor injection and inject task repository. I'm going to explain injection again in a minute. So if you go back to our task controller, you can see that we're directly using the repository inside these controller methods. We do not want that. So we're going to move these over to the service layer. So let's start by creating the get all tasks. Public list of tasks. Get all tasks. And here we're going to use the repository to find all. You can also copy and paste from the controller if you want. Then we want to get the task by ID. In here, I'm going to do something differently. So you can see this code works. We're going to find by ID. If it doesn't exist, we're going to return a null. But ideally, we would like to return an optional. This is going to tell whoever calls this method, and it will let them know that this method can potentially return a null, an empty object. So this is going to return an optional of task. Let's import this class. And over here, we can delete this or else, because this optional already tells the caller that this can be null. So in here, create task, we're gonna send the task to save, and again, update task. We are simply moving what we had in the controller over here, so you can literally just copy and paste and it should still work. Last but not least, and we also want the delete task. So I'm not going to repeat this because I already told you in the previous part how this works. And we've also got these 2 extra search tasks. Let's also add these. List task, get completed tasks, find by completed, true. And what else did we have? Actually, we want to pass the status. So in here, we want to accept a boolean as input, boolean status and status. And last but not least, search task by title ID. So let me just copy this. So search task by title ID, this is going to return a list of tasks by title. So our service layer is complete. You can see we are using the repository to talk to the database. Now we want to use this service class inside our controller. So the first thing we're going to do is, instead of having the task repository here, we are going to substitute this with the task service. So private final task service, task service. Instead of injecting the task repository, now we're going to be using the task service. And same over here. Let's remove that. What we want to do is we want to use the methods inside the service class that we have just created. We're going to have task service dot get all tasks. In here, we want to do task service dot get task by ID. And the rest is the same. If we find it, we're going to return a HTTP status OK along with the task. Otherwise, we return a response not found. So in task saved, instead of using task repository, again, task service dot create task. The rest is going to stay the same. Inside our update, we are now going to use task service dot update task. We're going to pass the ID, updated task. If it is successful, we return an OK, and if it doesn't exist, we return a not found. And let's do the same with delete mapping. So task service dot delete task. If this is successful, so if it returns true, we're going to return OK. So this is wrong. Sometimes Copilot is not always correct, so we need to be careful with AI. And let's move on to completed. Task service, get completed tasks, and we'll pass the status. So actually, now that I think this name does not really make that much sense. So let's rename this in our service class. Let's call it get completed tasks by status. Actually, get tasks by completion status makes more sense. And let's go back to our controller. Let's change also this last one to use the task service dot search task by title, and we'll simply pass the title we get as input. See how clean the controller is now. It's just handling HTTP concerns. All business logic is in the service layer. I want to talk to you about dependency injection flow in this change we have just done. So Spring is going to create the task repository. Spring then creates task service and injects the task repository. Then Spring creates the task controller and injects task service. What I just described is called inversion of control. Spring manages the object lifecycle, not us. And that is a very important concept, and it's something you should try and understand. So let's test everything. It should just work exactly the same, but now our code is much better architected. So let's run this. It's still starting successfully. Let's use our API tool and let's create a task and let's see if it works. Completed equals to false, title, task 1, refactoring. Let's click send and we can see we are still able to create tasks. Let's quickly do get task by ID and we can also successfully call the get endpoint. So what we have just done is refactoring of our code, and we have introduced a service layer between our controller and our task repository. It's very important when you're creating a Spring Boot application to have your code well organized. This is going to make your life easier in the future in case you want to add something to your code, or even if you just want to do some testing. If you're finding this video useful, please don't forget to like and subscribe, as making this kind of content takes a really long time. Right now, when a task doesn't exist, we return 404, but let's make error handling more robust with custom exceptions. So let's first see what is happening right now. So as I said, we are returning 404. For example, we call this getController. This getController goes to the task service. The task service goes to the repository and it finds a task by ID. And you can see this find by ID returns an optional, which we then have to handle somehow in our controller class. If the task is found, we return a response entity, okay. Otherwise, we return a HTTP status not found, which is equals to 404. Let me quickly show you that this is actually happening. So if we run our application, this is going to run our app with an empty database. So if we use our API tool to do a GET request, let's say get task with ID 1, you can see we get error request, response status 404, and status is shown also down here. But as you can see, this is not a very useful message to return to a potential client. We want this to look a bit better, and we would also like to avoid handling nulls in the controller or having to handle any kind of exception in our controller classes. So this is what we're going to be implementing now. We're going to do exception handling a bit better. So what we're going to be doing is improving our exception handling. Let's start by creating a custom exception. So let's create a new package called exception. In here, let's create a new class, and this is going to be of type exception, and we want to call it task not found exception. You can see we have a runtime exception called task not found exception created. Runtime basically means that any kind of exception that is thrown whilst the program is running is considered a runtime exception in very simple words. So if you click on it, you can see the official documentation. This is an unchecked exception, so it's something that we will only find out during runtime. We don't know about this kind of exception beforehand. And what we want to do is task not found exception is going to get as input a long, which is the ID of the task. And then it's going to create, using the super constructor, a custom message, task not found with ID, and the ID we have passed. So let's use this task not found exception, the new custom exception we have just created in our service class. Let's go to the get task by ID. We want to do find by ID, or else throw new task not found exception with our custom ID. So there is an error. Okay, so the error is because we are still returning an optional, so we don't want an optional anymore. we want to go to the controller class that calls that service method. We can now simply remove this from here. We can just do task service.getTaskById. There is still one more step missing, which we're gonna see in a couple of minutes, because you might be wondering, oh, what happens if the task is not found, if this task by ID does not exist. I'm going to do that in a second. We also want to remove this response entity, and we are simply going to return a task ID. So you can see we are now throwing our task not found exception, which is the custom exception we built, if the task is not found in the repository class. And in our controller, we have basically removed the response entity and we are simply going to return the task. But you might be wondering what happens if an exception is thrown. I'm going to show you in a minute. Before going there, let's go back to our service class. And let's also update our other methods. So for example, update, we have a find by ID. Let's change this and let's do or else throw task not found exception with the ID. And simply we need to change this. Instead of having the lambda, we are going to get this task saved in a task object. And then we simply update the task attributes. Let's fix indentation. Task repository.save. Again, we want to remove the optional. We simply return the task, because if it doesn't exist, we would already be in this throw condition. If we manage to save and update, we will have a task that we can return to our controller. So if you go to our controller, let's remove the response entity, and simply we can remove that and just keep task service.update task. Let's do the same for the delete. So if you go in the service class, so in here we have a find by ID, and let's do or else throw. So if we can't find it, we throw a custom exception and we pass as input the ID. And here we can now simply do task repository.delete by ID. Actually, we want to get the task. Yeah, so we don't want to do delete by ID, but let's just delete the task itself. And this is now going to return a boolean. This is going to be the task we retrieve. We find by ID, we get the task, and then we simply use the delete method in the task repository to delete the whole task instead of deleting by ID. And the return type is now a boolean. And our controller class is going to look way simpler. We simply do task service.delete task by ID. And if we manage to delete, here we still need to do a return response entity OK. And that's because we can't have a return. If we just had a void here, this would error out, as you can see. So that's why on the delete, we do need to return a response entity, and this OK is going to tell the user that the task was deleted successfully. We do need a return, otherwise they would not know what has happened. Okay, so you can see our controller is now looking slimmer, and in our service class, we are throwing this custom exception we have created. So you might be wondering, how do we handle these exceptions when they are thrown? To do that, we're going to be creating a new kind of class, which is called an exception handler. To handle these exceptions globally, we need to create a controller advice. So in our exception, let's create a new class, and we will call it global exception handler. So as I said, this is a controller advice. What this means in very simple words is that this class applies to all controllers. So what do we want to do? We want to handle exceptions. So we need the exception handler for the task not found exception, which is our custom task. So every time this custom task is thrown, this exception handler inside our controller advice is going to be called. And what do we want to do? We want to return a response entity with a map string of object. handle task not found exception. Import this map. Import is not working. Let me just do it manually. java.util.map. Handle task not found exception. As input, we'll have a task not found exception. And we also want the web request. And now what we want to do is we want to fill this map of string of object. Is going to be the body of our response. New hash map. And in this map, we're going to put a timestamp. Which is going to be local datetime.now. We are going to have a message, so body.put message x.getMessage, and also the path that has thrown the error. And this is where we need the request object, so we do request.getDescription false and replace the URI. So what is going to happen is now we're going to return a new response entity with a body, which is the map we have built, and HTTP status not found. So what is happening here is whenever a controller throws an exception, this global exception handler, which is a controller advice, is going to catch that exception depending on the exception that is thrown. So in this case, if the task not found exception is thrown, this exception handler is going to catch this exception and create a response entity with a timestamp, a message, and a path, and then return it to the client. And you can see the benefits of this. We don't have to do a catch every time inside our controller. And if we need to change something, we can just simply do it here. Let's also add another exception handler for all the exceptions. So exception.class. In this case, we do public response entity. Same as before, we want to return a map of string to object. And this is a handle global exception. And we're going to have an exception x web request. And in here, we are going to again create a map of string to object, which is going to be the body of our response. We do body.put timestamp. Let's add a message and let's add some details, which are going to be the message from the exception itself. And now let's return a new response entity with the body and an internal server error. So this is going to return a 500. So let's go back to our controllers. Good news, we do not need to change anything. We have already done the update as part of the change we did earlier to the service class. If you remember, it used to look like this. Now if a task exists, we return the task. If an exception is thrown, it will be handled by the controller advice. No more optional handling in the controller. Exceptions bubble up and our global handler catches them. Let me quickly show you how this looks like. So our application has started. Let's do a get request with task ID 1. We have more useful information and our error handling is now professional. The client gets useful information in a consistent format. We have the path, we have the message, and the timestamp. I hope you found this useful. If you did, please don't forget to like and subscribe, as making this kind of videos takes hours and hours. If you want to check out the code of this part, you can go on my Git repo and look at the merge request. Right now, anyone can send garbage data, empty titles, 10,000 characters for description. We need to add validation. To do that, we're going to be using Jakarta bin validation, which is going to make this very easy. So let's add a bunch of tags. So let's start from the title. We want the title to not be blank, so let's use not blank. And let's also add a message in case this validation is triggered. So in case the title is on blank, we'll show title is mandatory. Let's also add a size validation. So we want, let's say, at least 3 characters and a maximum of 100. And then we'll add a message saying title must be between 3 and 100 characters, and column, that's fine. And by adding these two annotations, we have added that this title attribute has to be not blank and it needs to have a certain size. Let's move on to the description. So let's add another size validation, and let's say this can be maximum 500 characters, and we're gonna add a message. So we have added Jakarta bin validation tags. There are also other tags you can use, such as not null. We then got email in case you want to make sure that that string is an actual email. And you can also have pattern, which is going to be using regular expression matching. So if you add this, and you can add the regular expression over here. So we have added validation, but this needs to be activated. I've just launched my new website, LeetJourney.com. You'll find one-to-one CV reviews, mock interviews, mentoring, and a blog with deep dive Spring Boot and software engineering content. If you find my videos helpful, you can also support the channel on Patreon or become a YouTube member starting from just 99 cents. It really helps me keep making free, high-quality content. Now, back to the video. So you can see we have added validation to these two attributes. We now need to activate this validation. To do that, we need to go in the controller, and wherever this is used, for example, it comes as the request body of the create task, we need to add @valid. By adding this @valid, we are going to trigger validation on this task class. All these validation annotations we have added will get activated. If you don't add this @valid, this is not going to work. Let's also add it down here in the update task. Let's do @valid, and I think that's enough. So this valid, as I said, triggers validation before the method runs. If validation fails, Spring automatically returns 400 bad requests. But let's make this error message better. To do that, let's go in our global exception handler. In here, let's add another exception handler, this time for method argument not valid exception. This is the exception that will be thrown by the Jakarta bin validation in case validation fails. And if validation fails, let's add a proper message, public response entity. Let's return a map of a string of an object. Handle validation exception. As input, this is gonna get a method argument not valid exception. And in here, let's create this map of string, object, body, new hash map. Let's add a timestamp. Let's add a message. So let's do put message. We'll say validation failed. And let's actually get which fields have failed validation. So let's do string errors. We take this exception, we get the binding result, we get the fields with the errors, and then we use a map to get the field with the default error message we had defined in the validation, and we save it as a list. We then simply do body.putErrors, and we return a new response entity, which is still gonna return a 404. This is a nice way to handle validation exceptions. Now let's try to run this, and let's trigger this exception. Let's see if validation is actually working. So let's run this. By the way, if you've been following this playlist from the beginning, you might have noticed that my IntelliJ has changed a little bit, and that's because JetBrains has released a new version of IntelliJ, so we don't have any distinction between Community Edition or Ultimate Edition. It's all in one, so that's why it looks a bit different, and the API tool I was using is not supported by this version, so I'm going to be using Postman. So let's create a new post request, http localhost 8080 API v1 tasks, and as body let's have a title. So let's send a valid request first, so we'll do valid description, valid, and what else do we need? We need the completed. Okay, so this is working, it was created, but let's see if it works if the title is less than 3 characters. this should fail. So we can see validation failed. Title must be between 3 and 100 characters. If we try to put description as a 1 character, this is still going to go through because description only has a maximum number of characters set. So let's go back here. Let's also add a minimum. Let's put 3. Let's restart and let's see what happens now. You can see we get a validation failed error, and in this case in the errors list we get both exceptions. Both validations for title and the description field have failed. You can go ahead and try with a description that is too long and see what happens. You will see that that is also going to fail validation. I hope you're finding this video useful. If you do, please don't forget to like and subscribe as it helps the channel a lot. Here is a problem. We are exposing our entity directly to clients. If you go in the task controller, you can see we are directly returning our task entity. What if we add sensitive fields in this task entity, such as internal flags, passwords, or sensitive data? What if we want different data objects for create and updates? What if we don't want clients setting the ID or create that? The solution to all of these are DTOs, which stand for data transfer objects. These are separate classes for input and output that just contain data. We can see in our controller that when we create a task, both the input and the output objects are the same task entity, and that's not good because this task entity, which is representing a row in the database, could have sensitive data. So we want to have these two as separate objects. So what we're going to do now is create a new class called task request, which is going to be a DTO that we're going to be using as input to the create task endpoint. So I'm going to create a new package called DTO, and in here I'm going to create a new Java record called task request. I want to add something here. So you can see this is not a normal class, but it's a record. Java records have officially been introduced in Java 16. Java records are best used for immutable data carriers, classes whose main purpose is to hold data and not behavior. So these are perfect for being DTOs. Java records are immutable by default, and they auto-generate constructor getters, equals, hashcode, and the toString methods. It's also a good way to reduce usage of Lombok. They can also be used together with Jakarta bean validation. So let's create this task request. So this is going to contain a string title, string description, and boolean completed. Let's also add validation, so not blank, and let's also add size. So we want size min equals to 3, max equals to 100. Let's fix indentation. Let's add a message. So this is supposed to be title, not name. So let me fix that. Let me remove that. We add message is title is mandatory, and let's add the message also here. Let's add some validation for the description. So we'll add size. Let's add a minimum and maximum. So this should be it. We have created our task request DTO. This will be used to send requests. Let's go back to our controller. So wherever we use task as input request, let's use the task request DTO. And we'll also need to change the service class to accept a task request. And before we save, in here we are going to do task, which is the entity task. So entity task equals to, let's call the builder. We need a builder tag on our entity. Let's do task, and let's use the builder to set each attribute using the task request DTO. Task.title, we get description.description. We'll do the completed. So if it's not null, task is whatever is in task completed. If it's null, we'll set it to false, and created that. This is not needed because we got this on create. So I think this should be fine. And now here we save the entity task. And as a response, we don't want to return the entity as we said. So we need to create a task response DTO DTO. So let's create a new task response, and this can be a record as well, because once we set this is not gonna change. So I think having this as a record, it's fine. We can simply add a builder, because when we're gonna be saving to this object, it's gonna make our life easier. In here we want a ID, title, description, boolean completed, and also the created at time, local date time created at. So let's go back. We need to go in the service method and change this create task to return a task response, and in here we now need to return a task response instead of the entity task. So let's extract this. Let's have this as a saved task. So we do task save task equals to task repository.save, and now we want to have a class called a mapper, which we're going to be using to transform from entity to a response and vice versa. So let's create a new package called mapper. In here we want to create a new class called task mapper. This is a component. That way Spring Boot is going to be automatically managing this bin for us, and we simply want to do public task to entity. As input, this is gonna get a task request, and this is what we did earlier in the service class, but this way we're gonna be using the mapper so that this is well defined somewhere else in our mapper class. So if we go back to our service class, we now need to do some auto wiring. So let's add task mapper, and let's use constructor injection to add that here. And now if we want to transform a task request into task entity, we are simply going to be doing task mapper to entity, and we'll send the task request as input. And we want to do the same thing. We want to be using the task mapper to now transform the entity into a response. So let's go back to our mapper. Let's create a new public task response to response. This is gonna take as input entity task, and we're gonna be using the builder from the task response to set these fields from our entity class. So if we go back to our service class, in here we do task mapper now dot to response, and we transform the entity into a response object, and in here we now simply have a task response instead of a task, and this is not gonna return a task anymore, but this is gonna be a task response. So you can see the task request is what the client sends, so there is no ID, no timestamp. The task response is what the client receives, and it's read only, and our task entity is used in the service class, so it's hidden away, and it's internal use only, and it's not exposed. So now let's change the rest of the code. So if you go back to our task entity, we can now remove validation from here, and that's because when we save in our DB, this is already going to be validated, so you don't have validation on entity classes. We're gonna leave the Jakarta bin validation on the DTOs, so in this case the task request and task response we don't really need it because this is set by us, but it's important on the input. In our controller, now let's go ahead and let's change this update. So this is gonna be a task request, this is going to return a task response. Let's go in the update task, so this will return a task response. This is a task request, and we need to do some changes. So you can see this has gone red. So let's use the mapper to add a new method that is going to update an entity from a request. So if you go in our task mapper, in here let's add a new method called public void update entity from request. We're gonna pass a task and a task request, and then we set the task attributes starting from the task request. So it's not null. So in here let's just have request.completed. So what this is doing is we'll pass a task, which is the task entity we retrieve from the DB, and the task request. We update the attributes in the task entity with what the user wants to update with. So we take this, we go back to our service class. So we need to change this. This is gonna take a task as input, which is that one, but before we set it as input, we're gonna do task mapper.update entity from request. We pass the task, the updated task, and we then send it to the save, and we can actually, let's reduce the lines of code. We do save, and then we do task mapper.to response, and this is gonna take the saved entity and transform it to a response object and send it back to the client. So you can see this is way easier now. So you can see how we have changed this code to have different kind of response and request object, and we have also hidden away the task entity. One thing I want to highlight is that for complex applications, you can use Mapstruct or Model Mapper to auto-generate mappers, but for learning, manual mapping helps you understand what's happening. Let's test this and let's see if this works. Let me run this application. I've just launched my new website, LeetJourney.com. You'll find one-to-one CV reviews, mock interviews, mentoring, and a blog with deep dive Spring Boot and software engineering content. If you find my videos helpful, you can also support the channel on Patreon or become a YouTube member starting from just 99 cents. It really helps me keep making free, high-quality content. Now, back to the video. So let's try to do a create with no valid inputs. So bad request. So validation is still working. Let's do valid, let's send. And you can see it has been created. Let's try to do a update. So let's do a put ID 1. So send that here, valid 22. Let's see. And you can see this has also been updated correctly. So the create and update we have changed are still working correctly as expected. If you go back here, as an exercise, you can go ahead and change this get as well. It's not too complicated. Actually, we can do it very easily. So this is gonna return a task response now. So that's the task response, find by ID, or else throw an exception. So let's take this out. Let's put it in here. So this is gonna be our task, retrieve task, and here we use the mapper, task mapper.toResponse, and we set the retrieve task, and this is gonna return a task response as well. And you can see it was super easy. You can go ahead and change this get task by completions as well. Actually, you do want to change this. We don't want to leave them like this. I'll let you do it, but it's the same principle. If you're finding these videos useful, please don't forget to like, as it helps the channel a lot. Thank you. Imagine you have 10,000 tasks. Returning all of them in one response would be terrible for performance and user experience. That's where pagination comes in. Spring Data JPA makes pagination incredibly easy. So let's update our repository class. So let's go to task repository and let's modify this. So these are going to stay the same. We are going to create new paginated methods. So this is gonna return a page with tasks, and we do find by completed. Again, this is gonna be the same as the one that already exists, so it's gonna take a completed, and it's also going to take as input a pageable. Make sure it's from the Spring Framework data domain, and we also need to import the page. Let's also recreate this find by title containing ignore case with pagination. So we do page, task, find by title containing ignore case. This is going to take as input a title, same as the one up here, but also this pageable. And finally, let's do the same for this one. So let me just copy this query. The query is going to be the same, and this is going to return again a page of task. Find task by completion status is going to take as input a boolean and this pageable. So you can notice we have both versions. One returns a list and one returns a page. Spring handles this automatically. Page over here is a special wrapper that contains the actual content, so a list of tasks, the total number of elements, the total number of pages, the current page number, and whether it's the first or last page. So if you go inside page, you can see it implements this interface, and you can see these methods that are available. And you can also see the get total pages and the number of total elements. Now let's go to the service class. Let's go to task service, and let's update the service class to use the paginated methods. So in here we can see get all tasks. It does find all, but let's create the paginated version, and this is going to take as input a pageable, and is going to call this find all with this pageable, and as return is not going to return a list of tasks but a page of tasks. So you can see this out of the box find all already has support for pagination. I've just launched my new website, LeetJourney.com. You'll find one-to-one CV reviews, mock interviews, mentoring, and a blog with deep dive Spring Boot and software engineering content. If you find my videos helpful, you can also support the channel on Patreon or become a YouTube member starting from just 99 cents. It really helps me keep making free, high-quality content. Now, back to the video. Now let's do the same for this method, getTaskByCompletionStatus, and let's create a paginated method. So this is gonna return a page of a task response, and we are also going to accept a pageable as input, and this returns a page task. We need to pass the pageable as input, and as return, we're gonna do completed task dot map task mapper to response, and this is the paginated method created. Let's now go to the controller. I think that's where it's more interesting. So let's go to the task controller and let's see how we can create a method that actually supports pagination. So let's see how this getAllTasks is going to look like when pagination is introduced. So let's create a new method called getMapping, and this is going to return a response entity, a map with a key string and an object, getAllTasks. And in here we need to request a bunch of parameters. So you have to think that this paginated method is likely going to be used by a frontend. So the frontend needs to send the backend which page and the size of the page the user has selected so that the backend can actually return the proper results, the ones that the user is looking for. So we need to request parameter. We set the default value to 0. So remember, this default value needs to be a string, and this is the page. We then got another request parameter, default value, let's put it to 10. And this is the size, the number of elements that the user wants for each pagination. And then we got another request parameter. The default value in this case is created at, and this is going to be a string sort by. And finally we also got the sorting. So in this case by default is going to be in descending order. So we first need to define the sorting. So we're going to build a sort based on field name and direction. So we do sort equals to sort direction dot equals ignore case if it's ascending order, then we're going to be sorting by ascending, otherwise by descending. And the next thing is pageable. We need to set the page request, so we need to define the page, the number of the page, and the size of the page. So for this page, the size means the number of elements that are going to be part of this page. For example, if it's the beginning one, it's going to be page 0. And the sorting. Once we have our pageable set up, we can actually do a call. So we can do page task, which is the response. This is going to return a list of tasks. So actually a task page. And then we can do task service, get all tasks based on this pageable criteria. Once we got that, we're going to have a list of task response as a result to be sent back to the user. So what we will do is we're going to get the content from the task page, stream it, and then we're going to create a task response and save it as a list. The last thing we're going to be doing in this map, we are going to be building our response. So this is going to be a hash map, and we'll put the response. So we'll do response.put tasks. Then we'll put the current page, the total items, the total pages, and also whether this response has a next, so has next, and if it has a previous. At the end, we're going to return a response entity with the response and status OK. Let's go through what we have just built. So we have a request parameter with defaults. So if the client doesn't specify anything, we're going to be using these defaults. We then have this sort object. We build this sort object based on the field name and the direction. We then build the pageable. This combines the page number, the size, and the sort into one object. And finally, the response structure is to return a custom response with pagination metadata, not just the data. This way, the frontend can send us another request when it wants the next page. The next thing we want to do is we want to test what we have written. So let's run our task manager. So we've got an error. Okay, so I think it's complaining about the name. Let's comment this out and let's retry. Yeah, so it was complaining because the names are the same and it's a bit ambiguous. So now we just got one get all tasks controller with a get mapping. And let's call this get all tasks. Let's go to Postman. And the first thing we want to do is actually we want to create some tasks. So if we create a post request to HTTP localhost 8080 API v1 tasks, and we want to give it a body title. Let's do test description valid. Let's also add completed equals to false. So let's call this few times. Let's create a bunch of tasks. So I'm calling multiple times. And now let's do a get request. So let me create a new request, get. And this time we can actually add some query parameters. So let's say we want the first page. We'll send page equals to 1, and you can see this has returned the second page actually. So if you want the first one, you should start with page 0. So this is page 0. You can see it's returning us the first results in descending order, and that's because the default we have set is descending. So if you want to set the ordering, we can do and sort direction equals ascending, and this should give us the task in ascending order, and it's working correctly. We can also set the size of the page. So we can add another query parameter called size, and we can set this to 5, for example. And you can see we only got 5 tasks back. And the other thing we can do is we can also sort by completion if we wanted. So we can add another query parameter called sort by equals to completed. So this has been sorted by completed, but of course every task is set to false. So you can do a combination of these query parameters, and these are going to affect your query. And this is a really powerful tool that is used in production applications. If you found this part useful, please don't forget to like and subscribe, as it helps the channel a lot. Now let's add flexible filtering. Real applications need to filter by multiple criteria. So let's create a new get mapping, and I'll show you how to add filtering to your application. Let's create a new search endpoint, public response entity. It's going to be a mapping object, and we'll call it search tasks. And as input, we're going to get request parameter. Required, we'll set it to false. String title. Another request parameter. Required is false, so it's optional. Boolean completed. And then the rest are going to be the same as our paginated request. So we're going to add page, size, sort by, and sorting direction. And now what we're going to be doing is very similar to what we already have in our getAllTasks method. So what I'm actually going to be doing is I'm going to copy the body of the getAllTasks, and I'm going to paste it in this new method. And now you can see we first have a sorting. So this is the sorting direction. This is going to be unchanged. Pagination mode, this is where we're going to be doing a bit of changes. So pageable is going to remain the same, but now task page is not going to be set to whatever getAllTasks was returning. So we'll leave it null, and we need to add a bunch of if else. So this is where we're actually doing the filtering. So if title is not null and completed is not null, then we want to filter by both, and we'll do task page equal to task service dot search tasks by title and completion, and as input we'll give title and whether it's completed or not. You can see this does not exist yet, but we'll create it in a minute. Let me complete this if else logic. Else if title is not null we want to filter by title only, and task page is going to be equal to task service dot search tasks by title. This already exists, but we don't have the pageable method. We need to add another else if. So if completed is not null, we want to filter by the completion status. Filter completion only. Task page equals to task service dot get tasks by completion. We actually have already a pageable request, so we will give completed and pageable. Why is this erroring out? Okay, so this is returning a tasks response. That's why. So we'll need to create another method. So let me just change it. Get tasks by completion, and we'll create this new method simply. Else, we don't want to apply any filter. We do task page equal to task service dot get all tasks, and as input we'll give the pageable. So the rest can stay the same. I think the rest is fine. Total has page. Yeah, I think the rest can stay the same. So let's start from the beginning. If you notice, we have put required equal to false on query parameters. This makes them optional. So we now need to add methods to the repository and the service so that this red is going to go away. Let's start by going to the task service. In here, let's create new methods. We'll just create them here at the top. Public page is going to return a task. Search task by title, and as input we'll have a pageable and the title. And this is going to return task repository. Find title containing ignore case, title, and pageable. This already exists, so we should be good. Let's create the other service method. Page. Again, this is going to return a task. Search tasks by title and completion. As input, we're going to get the boolean, the string title, and the pageable. And this is going to return task repository find by title containing and completed. So this is going to get title, completed, and pageable. So you can see this method does not exist in the task repository. So this is the next step. Let's go to the task repository and let's create this method. Let me create it here at the end. So this is going to return a page task find by title containing and completed. As input we have title, the boolean completed, and pageable. And this is going to be a query. So we have the query tag, and now we want to write our query. So I think the auto completion looks good. So let's check. Select T from task where lower, so we want to lower the title, is equal to, it's actually like, so it's going to do a wildcard match where in the middle is going to have the input title and the completed status we pass as input. And this is what we need. So let's go back to our controller. We can see we got an error here. Okay, so here we're passing a pageable. We forgot to pass the pageable in here, so let's add that. So this is gone. Get task by completion. We need to add this method in the service class actually, so we forgot about that. Let's do it. Public page task. Get task by completion. Completed and pageable. Find by completed, and this already exists. So if we go back to the controller, all the errors are gone, and we can see we have implemented filtering. So now let's run this and let me show you how this works. So if we restart our application, so it's complaining about the name of one of the task controller method. So it's saying there is already task controller bean method with search task by title, and it makes sense. We already have a get mapping for search. So let me change this. I'll have it search, and because this is by title, I'll just change it to search by title. So if we start now, this should work. So the application has started. Let's go to Postman. I've just launched my new website, LeetJourney.com. You'll find one-to-one CV reviews, mock interviews, mentoring, and a blog with deep dive Spring Boot and software engineering content. If you find my videos helpful, you can also support the channel on Patreon or become a YouTube member starting from just 99 cents. It really helps me keep making free, high-quality content. Now, back to the video. So let's create some tasks. Let's just create some random tasks. So 1, 2, 3, 4, 5, 6. And let me also create one with completion status as true. So this is task 323 and this is completed. Let's see what happens when we call this new endpoint we just created. So it looks very similar to the paginated get. So I'm just going to duplicate this and let's rename it to paginated and filter. And let me add a new filter, which is going to be completed, and we'll have it as true. So if you click send, it should only return those that have been completed. So this, for some reason, has not gone into the if else. So title completed. So we have set completed to true. So it has returned the last three. I'm just trying to understand why. Okay, makes sense. We are calling the wrong endpoint. We have to add search. So let's try again. And this time you can see when we add this completed equals to true, we get only those that have completed as true. Let's create a new task where completed is also set to true. If we go back to the paginated and filtered endpoint, let's call again with the same values. And you can see we're getting back tasks that have completed set to true. If we change this to false, you can see we get 3 back because that's the size of the page. And this time we get those set to false. So you can see this is very powerful. You can combine search, filtering, and pagination and sorting in one endpoint. For even more complex filtering, you would use Spring Data specifications or query DSL, but this scenario covers 90% of use cases. Real applications have relationships between entities. Let's add categories for our tasks. So let's create a new entity class called category. Let's call it category. We are going to require the entity tag. We are then going to add a table tag that is going to define the name in the database. So this will be called categories. Let's add a data tag to get getters and setters, no args constructor, all args constructor. The ID is going to be auto-generated, so we're going to add generated value with the strategy identity. Let's import, and this is going to be a private long ID. We are also going to add a name, so private string name. We are going to also add a tag. This is going to be column nullable equals to false, and we also want it to be unique. Description can be false, I think. Let's add a maximum length of 255, and that's all we need for now. Let's now add the category repository class because we need a way to interact with this entity in the database. So in the repository, let's create a new interface called category repository. Let's add the repository tag, repository, and this extends a JPA repository and it maps to a category class with an ID long. This is all we need for the category class. Let's now move on to the service class. So let's create a new service and we're going to call this category service. And we're going to keep this quite simple. So this is a service class. We're going to auto wire private final category repository. And what we're going to be doing here is we're going to be adding two methods, public get category by ID. So we're simply going to query the repository, and the other one is public category and create a category. So whatever is passed, we want to save it in the repository. Let's also add a new controller to create this category. So let's call it category controller. Let's add, this is a REST controller and it also has a mapping. So API v1 categories. Let's inject the category service, and very simply we're gonna have a get mapping. So we'll have get mapping public category find by ID, and we'll use the service class to find the category by ID. And let's also add a controller method for creating the categories. So public response entity category, let's call it create. As input, we're going to pass a request body, and this is going to get a category from the service class. So created equals to category service.create, and then we return the response entity with the body of what has been created. Okay, so far we have created a new entity, which is basically a new table in our database. Let's now create a relationship between this new category and our task entity. For that, let's go in the task entity, and in here, let's add a new attribute, which is basically going to be a new column that is going to reference the new category. So private category, this is a category as well. And we're going to add many to one, fetch equals to fetch type dot lazy. And let's also add join column, name equal to category ID. So what does this mean? Many to one basically means that many tasks belong to one category. And we also added fetch type lazy. That's because the default for many to one is eager, but we do not want eager. And that's because whenever we are going to be retrieving a task, if we did not add this lazy, JPA would retrieve the whole object for category. And if you had a lot of tasks, that would be quite inefficient. So what this lazy means is that only retrieve category when we actually access this category. If you did want this to be fetched all together, you could have eager over here. As I said, by default, many to one has this set to eager. But to make it explicit, you could just add this. I will move it back to lazy. That's what we want for now. And the other tag join column basically specifies the foreign key column name in the tasks table. So JPA now knows that tasks table and category are related to each other. So let's now do some more changes. So in our DTO, we have a task request. This is what we send when we create a task. But let's say on task creation, we also want to set a category for this task. So what we want to do is let's add a new attribute, which is going to be of type long, and we'll call it category ID. And same for the response. When we retrieve a task, we also want to retrieve the category if it exists. So let's have a category over here. I'll actually call it category info. Let's create a new DTO called category info, or actually category response maybe. Category response, let's create it over here. It's going to be a record, category response. So this is going to contain a name, so string name. We could also have the ID really if you want. So let's have long category ID and description. So in the task response, we are also going to be returning this category response, which is just another DTO. So the other thing we need to fix is in the task controller, because we now have an extra input as part of the task response and task request. In here, we need to add a null and another null down here while returning the response. Of course, you can go ahead and also modify this to return the actual category. I will leave them as they are because that's not our focus. The other change we need to do is actually in the task mapper. So in here, we do need to change our mapper methods. So for that, we need to auto wire private final the category service, because category is not compulsory. So it might be there, it might not be there. So when we receive a request, there might be a category ID, there might be not. So let's add that. We will do category equals to null, and then we'll do if request is not null and request dot category ID is not null. It means that a category probably exists. So what we're going to do is we're going to find this category by ID and we'll set it to this category object. Once we set it there, we simply just add it in the task builder. So we'll have category equals to whatever category we have retrieved. Same for the response. So what I'm going to be doing here is category response equals to null. And then we'll do if task is not null, which probably is not, but let's just add it there for completeness. And task.getCategory is not null. We are going to be doing category response equals to category response we forgot to add the builder in this record, so let's add it because we're going to need that now. So using the builder, let's create name, which is going to be task.getCategory.name and description. We can also add the ID. Did we add the ID to the category response? Yes, we did. So category ID task.category.getID. And when we return our response, we're also going to add the category we have retrieved. And you can go ahead and also change this update. It's not too difficult. Actually, let me just do it. If request.category ID is not null, let's retrieve the category and we just set it to this task. And it's as easy as that. And we're now ready to test this. So let me just run the application. Let's go to Postman. Let's first create a category. So let's create an urgent category for urgent tasks. Let's create a low priority tasks. And this is going to have ID 2. Let's now create a task which is going to have a category ID which is equals to 1. And you can see this got created with the correct category assigned, which is urgent. So let's create another one again for urgent, and let's create a third task with category 2. And you can see this is assigned low priority. Let's now try to retrieve these tasks. So we'll do get task by ID. Let's try to get task with ID 1, and you can see it's correctly getting retrieved. And it has a category assigned, which is in this case urgent. So this is wonderful. We now have relational data in our application. You could also go ahead and add an endpoint to get all tasks by category. Relationships are everywhere in real applications, and now you know the fundamentals. Right now, our configuration is in this application.properties file. Let me show you another way to define application properties using a YAML file. Some might argue that using a YAML file is a bit more readable because it avoids a lot of repetition. And also, in many of the projects on my channel, I've been using the application.properties, so I think it's only right I show you the other way of configuring application properties. Spring Boot loads configuration from either application.properties or application.yml. Let me show you this second way. So what I'm going to be doing is in here, I'll create a new file called application.yml. And now let me open these two side by side. So on the left, you have the current configuration, and here we want to define the new way of configuring. The way YAML works is it works in a hierarchical way. Spring is the top of the hierarchy, then this is the one that comes after. Let me just start writing and you'll understand. So we have Spring, application, name, task manager. You can see each dot in application.properties translates into a semicolon in application.yml and an indentation. Let's move on to the data source. So database configuration, you can see this is going to be at the same level as application, and that's because both application and data source come after Spring. You can see we avoid repetition this way. We are not repeating the same Spring dot or data source dot each time, but we just need to define it once. So URL jdbc h2 taskdb. We have driver class name, username, and password. Let's now define the JPA configuration. Very similarly, these are going to be at the same level as data source and application. We define the database platform, Hibernate, DDL auto update, and JPA show SQL equals to true. And I would say let's just add it after the data source, the H2 console configuration. So we have H2 console enabled true, and then we have console path equals to H2 console. So you can see we have translated these properties into YAML, and they kind of look more organized. I would also say easier to read because they're grouped in a logical way. So all data source properties are all here. H2 properties are here. They can become a bit confusing. You can just do this, for example, and you can see we have data source in between JPA. So this is not really nice. Let me delete the Application.properties, and let me run this application to show you that it actually still works. So if I run this application now with the new configuration file, application is starting fine. Let's go on Postman, let's create a category, and let's create a task. And you can see everything is still working fine. Let's now go back to our IntelliJ. So let's now see how we can define custom properties. Let's say there are some configuration properties that you don't want to put in the code. You want to have them in this external file, application.yml. Let me show you how you can do that and how you can read them in Java. So let's say you want to add some application related configurations. So let's call them app info, and again you're gonna have app, you will have a name, for example task manager, version, and let's say maximum tasks per page set to 10. Let's say you want to access this data in code. Let's say you want to create a new endpoint which is going to give application information. You can do that. So we are going to create a new controller called info controller. This is going to be a REST controller, request mapping, API v1 info. And now if you want to access those values in here, we need to do private string app name, and we need to use this tag called value. So make sure you don't confuse it with the one from Lombok. You want the beans factory annotation from Spring Framework. Then you want double quotes, $, curly braces, and here you simply put the name. So at the top level we had app, and then we have .name. And what Spring is going to do is going to inject this property value directly inside the string. So let me do it for the rest. Let's do it for app version. This is also gonna go in a string. And finally, we have max tasks per page. And again, this we're going to be using the value tag and double quotes, $, curly braces, app.max tasks per page. By the way, the name of the Java variables does not have to be the same as the properties. You can have anything you want. The name of the property is defined in the value. Let's now create a get endpoint. So get mapping, public map string object, get app info. We are going to be creating a hash map, and then we're going to be putting all the information in this hash map and return it. So we have our new endpoint. Let's rerun our application. There is an error here. Let's see. Play application run fail, info controller injection to our dependency fail. Why did it fail? Oh, app.name could not resolve this. Let's see. Okay, so it's because of the indentation. When Spring tried to read this would read spring.app, and for that reason it needs to go on its own indentation level. So let me just change that. Yeah, so indentation is important in YAML. Let me just try and rerun this application. You can see it's now running fine. So if you go on Postman now and you try to call that endpoint, let's see what happens. You can see we are correctly returned the result from the configuration file application.yml. So this is nice and useful for a few properties, but let's say you had way more property than these. Let's see how to do that. So for that, we're going to be creating a new controller. I will call it advanced, info controller advanced. And again, this is going to be a REST controller. Request mapping is going to be API v1 info advanced. And let's see how this is going to look like. So before we go on and we create a new endpoint, let's create a new package called config. In this package, we want to create a new class called app properties. And what we want to do here is this is going to be a configuration class. And this is going to use configuration properties tag to load all the application properties that start with this prefix, which is app. And let's add getters and setters to access these properties. So we'll have private string name, private string version, private int, max tasks per page. So I think in this case, name is important. So it will try to load all the properties which start with app.name.version. So I think naming here might be important. So what is going to happen here is that using this configuration property, Spring is going to inject all the properties it finds in application.yml inside these attributes. And we can go one step further. We can also add validation. So we can use tags such as not blank. We can use again, not blank for version. And for example, we can have a minimum number of tasks per page, let's say 1. And let's say the maximum we want it to be 20. If properties are invalid, the app will not start. So this prevents misconfiguration in production, for example. Let's now go back to our controller. Let me show you how to use this. So we're going to be injecting that configuration class doing private final app properties, and then we inject it in the constructor, and simply we create a new get endpoint, get mapping, public map string, object get info, and we do the same as before. We do map.put, app name is going to be app.getProperty, and it's going to be app properties.getName. We do the same for the version, so we do map.put version, app properties.getVersion, and same for map.put max tasks per page. We get them from our configuration class and we return this map. Let's rerun this application and let's see how this looks like. The application is running fine. If we go on Postman, let's call the advanced endpoint. If we click send, you can see we still get application results. Just the order is different, but that's fine. You can handle that. If we go back to our code, you can see that this way is much cleaner. You can also validate properties with bean validation, as I showed you directly in app.properties. I also want to talk quickly about profiles. Different environments need different configurations. For example, in development, you might be using a H2 database, but in production, you might be using a PostgreSQL, and that's where Spring Profiles solve this issue. So for example, you could have a different application.yml file for production, which would be called something like application-prod. And in here, you could define production properties. So for example, in production, you might not want to show SQL because you might contain sensitive data, so you could set this to false. You could also decide to have a different password in production or have like a totally different database. You probably don't want a H2 database in production, so you could define a different kind of database for that case. And you can do this for any kind of environment you have. So for example, let's say you've got staging, you could create another configuration called staging. And in here, you could add a different property. You do not need to define all of them. So for example, the app property, you can remove it from both prod and staging. And what Spring is going to be doing is going to be looking at whatever is in application.yml. That's how this really works. And you might be wondering, how do you define what's the active profile? So all of these are called profiles: prod, stage, dev, whatever. And you need a way to define these active profiles. And for that, there are different ways of doing it. So for example, you could define it in here. In application.yml, you could have profiles active dev. This is the typical one. In application.yml, you usually have dev. And then when you deploy in production, you override. And there are different ways of doing that. One of them could be via environment variables. So for example, when we run our application, we have the possibility to pass environment variables. So you could do something like Spring Profiles active equals to prod. And what this is going to do is going to be using the application prod profiles when running. You can see if we run that application with that environment, it says the following one profile is active, and this profile is called prod. So you can see how powerful this is. This is just one of the ways of defining active profiles. Another one is also via command line. And something else that Spring Profiles allows you to do is you can actually create beans that are profile specific. So for example, let's say in here you have a class called data source config, and you could have something like the following. Let's say when you're using the dev profile, you want to use the H2 in-memory database. So you want to create this bean, and this bean will only be created when this profile is running. And for example, in production, you could be running PostgreSQL, and for that, you want to use a different kind of data source, and that's when this bean will be created. So it's quite a powerful tool that you can combine together with application.properties to configure your application in different ways, whether it be in production or in staging or any other kind of profile. When your application is running in production, you need to monitor it. Is it healthy? How much memory is it using? Are there any errors? For that, Spring Boot Actuator provides this out of the box. What we need to do is go to our pom.xml file and we need to add a new dependency. This dependency is called Spring Boot Starter Actuator and it's from the Spring framework. Let's sync with Maven. And now let's restart this application and let's look at the logs. So you can see in the log lines, we are exposing one endpoint beneath base path, which is called Actuator. Let's actually call this endpoint and let's see what's actually happening. So let's create a new request, Actuator, and this is going to be HTTP localhost 8080/actuator. And this is what we see. We have some health endpoints. By default, only the health endpoint is exposed. Let's actually call this endpoint and let's see what we're showing. So it just says status up, literally doesn't give us much information. And because there is only one endpoint that is exposed by default, let's expose some more. Let's go in our application.yml and in here, let's add some more properties. So it should be actuator configuration, management, endpoints, web exposure. And in here, we want to include health, info, metrics. Let's add env, loggers, beans, and mappings. And the base path in here is going to be actuator. Then we also want to add endpoint, health, show details equals to always. And we want to have information about environment and enabled equals to true. And we can also have information about the app. It's going to be very similar to this one. So let's have info, app description, and the version. Let's also add author, LeetJourney. And let's restart this application. And let's go back to the actuator endpoint. And let's see what's happening now. So if we call the actuator endpoint, you can see all of the actuator endpoints that are now being exposed by our application. Let's go to the health one and let's see how it looks like now. So this one is still looking the same. I was expecting a bit more detail. Let's see if the info one is showing anything. Yes, so this information actuator endpoint is showing the information we set for our application. Let's look at the metrics. This metrics endpoint lists all available metrics, and to see a specific one, you can just copy any name and you can just paste it as a path variable. And you can see the metric you actually wanted to check. We also have the environment endpoint, so you can do actuator/env. And this is going to give you the active profile. So you can see right now the active profile is dev and it gives you a bunch of other informations as well. Another endpoint that might be useful is the beans. This endpoint lists all Spring beans in our application context. This is great for debugging and dependency injection issues. We also have this other endpoint, so this is also a useful one, mappings. This gives us all the endpoints that are available in our application. So let's see if we can find the ones we have created. So for example, let's see if we can find the one for tasks. Let me just search. Here we go, we got the update, which is API v1 tasks ID, the kind of object is expecting, and etc. So again, if you don't know about an application, and if this actuator endpoint is exposed, you could use this to find some more information. One thing to notice is that in production, you do not want to give access to these actuator endpoints because they might pose a security risk. So use them carefully and make sure you only expose them in environments where there is no sensitive data. And with this, we have reached the end of this course, from beginner to intermediate. There is one more topic though that you should know as an intermediate Spring Boot engineer, and I'm talking about unit testing. For that, I have already created a comprehensive video, so please check that out. I'm going to leave a link in the description below. Spring Boot is just the beginning. The Spring ecosystem is massive. There is Spring Cloud, Spring Data, Spring Integration, Spring Batch, and many more. So this is just a small part. A single course cannot give you everything you need to know, but I think this was a very good beginning course to take you from a beginner level to an intermediate level. This is literally what they build in industry. Most of the times they're just building APIs and endpoints with some database attached to it. So I think this gives you a very good base on building your future applications. So you might be wondering what is next. So what you could do is build variations of this project. You can add more features to this task manager. For example, task assignment to users. So you could add a new entity class, which is users, due dates, and etc. Improve on what we have built. So you can add comprehensive validation, implement soft deletes, implement caching, add rate limiting, but I would say those are more intermediate to advanced level topics. I hope you found this useful, and if you have any requests for any kind of topics, please leave them in the comment box below. And also please don't forget to like and subscribe, as making this kind of content literally takes months.